right, last example for 2.3. This is number 6. And in number 6, we finally see a little bit of a flop from our a squared minus x squared. So in this one, we're seeing the variable come first, which means it gets a little tricky to use sine squared minus 1 equals cosine squared. You can try and mess with that by factoring out a -1, but even then you'll get in trouble because that'll leave you with a negative times a perfect square under the square root, which is not so great. So, alternatively, excuse my yawn in the middle of the afternoon, we know that tangent squared theta is equal to secant squared theta minus 1. So we can use secant as part of our substitution here. So I'm going to replace z's with 2 secant theta, which means that dz is going to equal, and some people have derivative of secant memorized. I don't make people memorize it. I often forget what it is. So it's up to you. Here, I better write this carefully. Okay, so remember that secant is 1 over cosine, so we can think about that as cosine to the -1. Be careful about how you write it. If you put the -1 on the cosine, excuse me, that actually means inverse. So we can do this with a chain rule. The negative drops down into the front. It becomes cosine to the -2. I guess I'll stick with the way I was writing it before. And then we have to multiply by the derivative of the inside, which is a minus sine theta d theta. Okay, so we have the two negatives cancel out. We have a 2 sine theta over cosine squared theta d theta. And you can certainly leave it like that. If you prefer, excuse me, you can rewrite it what you'll see in calc books if you look for a list of derivatives. Why so many yawns all of a sudden is that the derivative of secant is secant times tangent, and that's actually hidden in here. We have a sine over a cosine, which is a tangent, and then that leaves us with a 1 over cosine, which is a secant. So that's fine as well. It's up to you. So maybe we'll try the secant tangent and see if we have to rewrite later. Okay, so this turns into 2 secant. When we square that, we get 4 secant squared theta minus 4 raised to the 3/2. All over 2 secant theta, and then that gets multiplied by a 2 tangent theta secant theta d theta. And I think I like that I rewrote it because it makes it really easy to see that I can cancel a 2 and a secant. And then in here, if I factor out the 4, secant squared theta minus 1 is left, which means that's a 4 tangent theta, tangent squared theta, which means when we take its square root, we have the integral of, where are we at? So we have a 4, oh, here, I'm just going to write this out. I have a 4 tangent squared theta. It's not square root, it's 3/2 power, times tangent theta d theta. Okay, so 3/2 power. If we take 4 and square root it, we get 2. And then if we cube it, we get 8. If we take tangent squared, square root it, we get tangent. And then we cube it, we get tangent cubed theta. Okay, and this looks kind of horrible. Tangent to the 4th theta d theta. But I know how to get somewhere with a tangent squared, so let's see what we can do with that. We can say 8 times the integral. Okay, so if I had a tangent squared, I would replace that with what do we want? A secant squared theta minus 1. That same thing I used earlier. And then if I multiply that through, I get 8 times what do I have? Secant squared theta times tangent squared theta. And where are we at? Minus tangent squared theta. That seems unproductive. Let me stare at it for a second. Actually, I think I kind of like it, because that tangent squared theta is what we just messed around with. So now we've kind of freed one off from the product. So we can say we have a secant squared theta, tangent squared theta. And then, oops, let me not get it backwards. Secant squared theta minus 1. Okay, good thing I left lots of room for this one. It's a mess. Secant squared theta, tangent squared theta. I'm going to separate this off. Oops, off. Maybe I'll wait for one more step. So I have a minus secant squared theta plus 1 d theta. Okay, so now I think I'm going to separate it off. So I have 8, I'm going to bracket. So I have a secant squared theta, tangent squared theta that I still need to worry about. But I can actually integrate the secant squared. We know that secant squared is the derivative of tangent, so that's actually nice. And we can actually integrate the 1 and get a theta. We're going to save up our plus c's for a little bit longer. But how the heck do I deal with secant squared times tangent squared? I know a lot of people would stare at that one and feel kind of stuck, but that's actually a rather nice one because the derivative of tangent is secant squared, so we can w substitute our way out of it. So if I let w equal tangent theta, then dw is equal to secant squared theta d theta. So I can snag the secant squared and the d theta, and I can replace those with dw. And then the tangent squared theta is just a w squared. And then we still have that minus tangent theta plus theta. Okay, and then one more step I'll throw in the plus c after I'm all done integrating. Alright, so the integral of w squared with respect to w is going to be w cubed over 3. Okay, now I'm going to slap on the plus c. And then let's see if we can work our way backwards out of all of that. Okay, so first the w was equal to tangent theta. So we have an 8. I'm going to go ahead and distribute through as well. So I'm going to say I have 8 times 1/3, which is 8/3, tangent cubed theta minus 8 tangent theta plus 8 theta plus c. Okay, that's better. Gotta go back a little further because we didn't start with thetas. We started with, oh my gosh, it's a long ways back. We started with z, and I know that z is equal to 2 secant theta. So down here, if I know that z is 2 secant theta, then z over 2 is equal to secant theta. Or, if you like it better, cosine theta is the reciprocal, which is 2 over z. So if I draw my triangle, we're going to go adjacent over hypotenuse, and that means that the opposite is the square root of z squared minus 4. And you'll generally see those square roots you started with showing back up. So if you don't, you get some other weird square root, you might want to look around and see if you made a mistake somewhere. Whew. Okay, and this was my theta. So let's go for it. From that, I can say that tangent theta is the square root of z squared minus 4 over 2. Cubed. And then, okay, if we want to solve for theta, there's more than one way to do it. I'm just going to use the cosine that I had and say that theta is equal to inverse cosine of 2 over z. funny angle for writing. Okay, one last step to simplify because I have a huge mess. When I cube in that first set of parentheses, I'm going to get an 8 over 2 cubed, which is 1. And then I'm going to have a 1/3 z squared minus 4 to the 3/2 minus, we can cancel here, we get a 4 square root z squared minus 4, and then a plus 8 times inverse cosine 2 over z plus c. Whew, okay, messy one is your last one. Thanks for watching.